So you're trying to find a limit without your calculator. You have tried direct substitution and that doesn't work. You notice that you cannot cancel anything, so the cancellation technique doesn't work. So now what do you do? Well, actually there is another method. At the end of this lesson, you'll be able to find a limit using the rationalization technique. The rationalization technique basically works if you have some sort of square root in either your numerator and denominator. And I'm going to guide you through this. It's going to involve something that's called multiplying by the conjugate. So let's go ahead and get started on some examples. First of all, you'll notice in problem number 5 that we want to find the limit as x approaches 0. The first thing that we always want to do is to actually try to plug in 0. So if I try to plug in 0 for the x's, when I do that, I'll get square root of 2 minus square root of 2 over 0. I get 0 over 0, and again, I'm not allowed to divide by 0, so that doesn't mean my limit doesn't exist. It means I can't use direct substitution. So since there are square roots in the problem, I am going to use the rationalization technique. I'm going to rewrite the numerator. And since the numerator is the part that has the square root in it, we're actually going to multiply by the conjugate. The conjugate of the numerator is the same thing, but instead of a minus sign, you're going to get a plus sign. So what I'm going to do is multiply the square root of x plus 2 plus the square root of 2. And of course, whatever you do to the numerator, you have to do to the denominator, because otherwise we would just be breaking the math law. So that's what I'm going to do, because really notice we're just multiplying by 1. So now what I'm going to do is actually multiply the numerators and then multiply the denominators. When I multiply the numerators, I'm going to go ahead and use the distributive property. So I'll take the square root of x plus 2 times the square root of x plus 2, which will give me just x plus 2. And then when I take the square root of x plus 2 times the square root of 2, I will get plus square root 2 square root x plus 2. And now when I take my minus square root of 2 times the square root of x plus 2, I'll get minus square root 2 square root x plus 2. And then minus square root of 2 times square root of 2 is minus 2, because the square roots cancel out. And then all over. When I multiply the denominators, I am not going to multiply them together. I'm not going to distribute. I'm just going to leave the x on the outside and then put the other term on the inside. Okay, so we're not going to actually multiply it out. All right, from here, I notice that these two terms are going to cancel each other out, and then I also notice that my 2's are going to cancel each other out. So the only thing that I'm left with is the x up top, and down below I'm left with the x, and then I'm also left with what's in my parentheses. Okay, and then from here, I notice that my x's can cancel, so now I'm just left with 1 over square root x plus 2 plus square root 2. Now from here, remember the whole reason that I wanted to do that was so that I could use direct substitution. So now let's see if I'm able to plug in 0 for my x. So when I do that, I'm going to get 1 over square root 0 plus 2 plus square root 2. That is going to give me 1 over square root 2 plus square root 2. So I'll get 1 over square root 2 plus square root 2 is equal to 2 square root 2. I was able to find an answer, so that is my limit. You will notice over here, when we do this, this actually creates a difference of squares, and since one of them ended up being minus and one of them ended up being plus, this will always happen, that the two inner terms will cancel each other out. All right, just in case that didn't totally make sense to you, let's try another one just to make sure we got it. So this one, again, the first thing that I'm going to try is direct substitution, so I'm going to plug in 3 for my x values. And when I do that, I'll get the square root of 4, which is 2. So I'll get 2 minus 2 over 0. That gives me 0 over 0. Again, can't divide by 0. Doesn't mean the limit doesn't exist. I just can't use direct substitution. I do notice that there is a square root, so I am going to multiply by the conjugate, just like I did before. Okay, the conjugate of this would be the same thing, except instead of the minus, there's going to be a plus. And then I have to multiply the same thing on the denominator. Okay, so I've done that. Now, we're going to multiply across the numerator. I am going to skip a step this time because I remember those two middle terms canceled each other out. So I'm just going to do the ends of the problem. So the square root of x plus 1 times the square root of x plus 1 is equal to x plus 1. And then minus 2 times 2 is minus 4. Okay, and then from there, again, in the denominator, I'm not going to actually distribute. I'm going to leave them as two separate parts. Okay, now up top, when I simplify, notice that I end up with x minus 3 over x minus 3, and then the square root of x plus 1 plus 2. Notice nice things will always happen as you're working these. I notice that my x minus 3, since they're identical, I can go ahead and cancel them. So now I'm left with 1 over square root x plus 1 plus 2. Now remember, the whole goal in doing this was that I could actually direct substitute. So now I'm going to see if I can plug in the 3. So when I plug in 3 for x, I'll get the square root of 3 plus 1 plus 2. So now I'm going to get 1 over the square root of 4 plus 2. The square root of 4 is 2, so 1 over 2 plus 2, I get a limit of 1/4. And there we go. So hopefully now you can find a limit using the rationalization technique.